We finished example 2 in the last video. Let's move on. So we come to, well, this MC question from 2005. Now the first statement is that when a parachute is falling with uniform velocity in air, the acceleration of the parachute is 0, because that's the definition of uniform velocity, no change in velocity. So the first statement is correct. So true for first statement. How about the second statement? Now for the second statement, let's look at it. When a parachutist is falling with a uniform velocity in air, the gravitational force acting on the parachute is 0. Oh, this is nonsense. False. Because W equal to mg is a constant. It can never be 0. So the answer is true, false. I think it's part is C. It's option C. Okay, let's move on to the next question. A-level question. A ball bearing is dropped into viscous oil. Which of the following correctly describes its motion before terminal speed is reached? Its velocity increases acceleration. So acceleration must decrease. So it's either A or D. And then the velocity increases from 0 to the terminal velocity. So the answer is D. Answer D. Same as in air, but it takes shorter to reach the terminal velocity. So it's D. Okay, now we come to this question, Q10, and an object is projected vertically upwards. F denotes the magnitude of the force acting on the object. Oh, question is gone. And W denotes the magnitude of the weight of the object. If air friction is not negligible, which of the following statement is correct? When the object is moving up, F is greater than W. The net force is greater than W. So 1 is correct. Because air resistance X downwards, so net force is equal to mg plus r. Okay, so the downward net force is equal to that. So we come to the second statement. When the object is at the highest point, F is equal to W. Correct. So air resistance, since object at rest, air resistance is equal to 0. So net force, or F, equal to mg. Okay, and then the third statement, when the object is moving down, F is smaller than W. Correct. Correct. Since it's moving down, the air resistance acts upward, as upward. So the downward net force is equal to mg minus r. Is equal to mg minus r. So 3 correct. So the answer is D. So the answer is D.